Hello and welcome to Engineers Mindset Academy. So in today's video, we are going to begin a series on applied mechanics, which can also be called vector mechanics. Now in the first series, we are going to be doing resolution of forces in two dimensions, as can be seen on the board. It can alternatively be called two-dimensional force analysis. Now, what is a two-dimensional force? A force is said to be a two-dimensional force when it exists between the x and y coordinate Cartesian system, making an angle either to the horizontal or to the vertical. Now, let's take a look at the coordinate system on the board. This is what is called a two-dimensional Cartesian coordinate system. Why? Because we just have x and y components on this plane. So it is called a two-dimensional plane. So such a plane which involves just the x and the y direction or components are called a 2D plane. Okay, we call this a 2D, D for dimensional, and this is simply saying two-dimensional because we have just x and y plane involved. Now, just like we said, when we have a force which exists in between the x and y plane, let's call this F1, making an angle either to the horizontal, you can call this theta, or making an angle to the vertical, you can call this beta. All right, so such a force F1 is said to be what? A two-dimensional plane, because it exists between the x and the y coordinate Cartesian system. So which means if I also have another force here, let's say I have force F2 in this direction, same thing, making an angle here, let's call this alpha. Also making an angle here, let's call this beta. All right, so far as this force is making an angle either to the horizontal or to the vertical, then force F1 and F2 is said to be a two-dimensional force. Now, majorly, forces are meant to be in one dimension and not to be in two dimensions. So whenever we encounter force in two dimensions, the first thing that comes to our mind is always to resolve these forces to be in one dimension. What does it mean to resolve this force to be in one dimension? It means that these forces has to be on the same plane as the x and also as the y components. Okay, it has to be on the same plane as the x and as the y. So it doesn't have to exist in two dimensions. It must always be what? Either horizontal or it must be vertical. Now let's take a look at the plane. If you notice, we have positive x here and we have negative x here. This line is a horizontal line. So which means whenever we resolve our force to the horizontal line, we call that horizontal component of force. So if we resolve each of these forces now to the horizontal line or to the x line, it can either be called the x component force or simply horizontal component of force. Okay, we call that horizontal component of force because we are resolving that force now into the horizontal line. So it's simply called horizontal component of force. Now we have that if the force points towards your right in this direction, then it is what? A positive horizontal component force. If it points towards your right, it is positive. But if the force points towards your left after resolution, then it is what? Negative component. So that's the reason why you're seeing positive x here and you're seeing negative x here. So if it points towards the left, okay, once the arrow of this force points towards the left, then it becomes negative. If it points towards the right, it becomes positive. Similarly, if I resolve this force to point in the vertical line, then we call this vertical component because this line is purely vertical. So resolving any force in the vertical direction, we call that vertical component of force. Okay, vertical component of force. We call that vertical component of force. And if you also notice the arrow directions in this vertical component, notice that when the force points upwards, it is called positive. But once the force points downwards, so you have to also monitor the direction of the arrow of the force. If the force points downwards, then you have it to be negative. But if it points upwards, you have it to be positive. So that is the idea behind this two-dimensional plane. Now, in resolving a force to two dimension, the first thing that comes into your mind is applying your vector form or applying everything you know on trigonometry. For instance, let's say this force F1 is a 10 newtons force. Let's say this force, okay, F1 is a 10 newtons force. So for instance, let's say this force F1 is a 10 newtons force and it makes an angle of 60 degrees to the horizontal. It makes an angle of 60 degrees to the horizontal, and you're asked to find the resolution of this force in both x-axis and in both y-axis. So simply finding what the horizontal component of the force, which represent the x-axis, and the vertical component of the force, which represent the y-axis. The first thing that comes to your mind is resolving this using your trigonometric rules. For instance, if I draw an imaginary line from the tip of this arrow now, if I draw an imaginary line, I will notice that this automatically have become what? A right angle triangle. So which means I am going to make use of what? My trigonometric rules to resolve these forces in both x and y axis. Now let's pull out this particular force and analyze over here. So I will have this to be my force, and then I have this to be my horizontal, and then I have this to be my vertical. Now remember, the angle between them is what? 60 degrees. So let's just put out these planes and see. Okay, so this is my y plane and this is my negative y plane, whereas this is my negative x, and of course this represents my positive x. So this is just a situation of what I have here. With this force F1, the magnitude of the force is what? 10 newtons. Now this 10 newtons represents the hypotenuse arm of this right angle triangle. So obviously this becomes a right angle triangle. Now resolving this force in the x direction, we can simply call this f of x, which means resolving the force in the x direction, which takes the horizontal components. Whereas resolving the force in the y direction, we can simply call that f of y, which means force in the y component, and this is force in the x component. So this indicates what? The vertical line y, and this indicates the horizontal line x. Now if you're applying your trigonometric rules, we can simply use a shortcut, SOHCAHTOA. Okay, this is a shortcut to all trigonometric rules, SOHCAHTOA. Now where SO stands for opposite all over hypotenuse, and hypotenuse arm is what? The magnitude for which is 10 newtons. The opposite arm is simply, in this case now, opposite is the side that directly faces the angle. So f of y is directly what? Facing this angle, 60 degrees. So which means f of y becomes the opposite of this angle, and of course the longest arm remains the hypotenuse arm, which is 10 newtons. So if we employ sine 60, which is now sine theta, is equal to opposite all over hypotenuse. Opposite all over hypotenuse. So this is equal to, our opposite arm there is what? F of y. So we simply put it down, f of y all over, the hypotenuse arm is what? The magnitude, which is 10 newtons, all over 10 newtons. Okay, so relating these two together, sine 60 is actually what? F of y all over 10 newtons. So I can easily cross multiply here. Remember, sine 60 can also be the same thing as what? Sine 60 divided by 1. Any number or any value or variable divided by 1 still remains that variable. So if I have 5 divided by 1, it still remains 5. If I have 20 divided by 1, it still remains 20. So which means sine 60 divided by 1 still remains what? Sine 60. It doesn't change. Now this helps us to easily what? Cross multiply. 1 multiplies everything up here, which is f of y, and then sine 60 multiplies everything down here, which is 10. So which means you have here 1 times f of y to be equal to what? 10 times sine 60. So 10 multiplies sine 60, f of y multiplies by 1. So if I do this, I'm going to have that 1 multiplies f of y still remains as f of y, and that's equal to 10 sine 60 becomes 10 times 0.8660. So which simply means that the resolution of this force in the y component becomes 10 times 0.8660, which will give us about 8.66 in newtons. So which means this force in the y component is what? is 8.66 newtons, and the direction of the arrow, mind you, in this case now the arrow will point vertically upwards. This arrow will point in the direction, so f of y is positive. The arrow points upwards simply because we have this the arrow line pulling out from the origin. If the arrow line is pulling inwards the origin, if the arrow line is pulling towards the origin or inwards to the origin, then you're going to have this force to point where vertically downward. But because the arrow sign is pulling outward from the origin, it means that f of y becomes what? Vertically upwards, and it makes it what? A positive force in the y direction. So this is now the vertical resolution of what? The force, 10 newtons. Okay. Now to resolve the force in the x-axis, still the same thing, you also employ what? SOHCAHTOA. In this case now, f of x appears to be what? The adjacent side to this angle. It's not opposite to the angle, so it's simply adjacent, which means you can employ what? CAH, which states cos theta is adjacent all over hypotenuse. Hypotenuse arm still remains 10 newtons. So we can simply what? Employ CAH to solve that particular problem. Let's do that over here. So we have that cos theta, or in this case now, cos 60 is adjacent all over hypotenuse, which is equal to, adjacent there is f of x, all over hypotenuse remains 10 newton, which is the force itself. So the adjacent arm is the force in the x direction. All right. So like I said, this can now simply be written as cos 60 to be equal to f of x all over 10. Okay, now I said you can also call cos 60 to be what? Cos 60 divided by 1 for easy cross multiplication. So 1 multiplies f of x, cos 60 multiplies by 10. Therefore, if I carry this out, I'm going to have 1 times f of x to be equal to 10 times cos 60. Okay, and if I do this, I'm going to have that 1 times f of x remains f of x, and that's equal to 10 times cos 60 itself is 0.5. We have this, so this simply implies that f of x is equal to 10 times cos 60 gives us 5 newtons. Again, since this force is pointing outward from the origin, then this is going to point in this direction horizontally, and it is positive because it points to the positive direction of x. But if the force is pointing into the origin, then it's definitely going to be what? Pointing to the negative side, which becomes negative. Okay, so these are the resolution of these forces in the x and also in the y direction using your trigonometric identity, or simply the short form SOHCAHTOA. But what if a situation where you have more than one force, like in this case now, I'm seeing F2, what if there is F3 and F4? You don't always have to go through this rigorous exercise to solve this problem. Okay, so there is a very simple shortcut which I have always used over the years, and it has been working for me, and it's perfectly okay, acceptable anywhere. You can use it and it works very fine. Okay, to also tackle this given problem. So you have to solve it at your own comfort, and you still obtain the same result without going through this whole rigorous exercise. Now, what is this shortcut? Let me show you. So I will take off here now. Okay, so instead of cleaning the answers, I will just leave them to, okay, for verification purposes. Now, this shortcut I'm going to take you also shows you the direction of the force in a very simple way, and also show you how to find the magnitude of the force also in a very simple way. Now, I want to resolve this force in the x direction. The first thing I will do is not to put it in equilateral triangular form. I will just simply solve it in this manner. Okay, so I think I will take this off as well. Okay, so I'm simply solving with this now. I'm not going to put this in triangular form. I will just leave it like this and solve with it like that. Now, how do you solve this, or how do you resolve this force in a horizontal and vertical component using this shortcut? So 3 things you need to keep in mind using this shortcut. The first thing is hold the tip of the arrow of the force and pull it to any of the direction you want to resolve the force to. That's the first thing to do. Hold the tip of the force, pull it to any of the direction you want to resolve to. Second thing you have to consider is observe the direction of the arrow, whether it points to your right or it points to your left. Okay, observe the direction of the arrow, whether it points to your right or whether it points to your left. That's the second thing to consider. The third and the final thing to consider is if the force passes through an angle to that given direction, then multiply the force by the cosine of the angle it passes through. Else, multiply the force by the sine of the angle it does not pass through. These are three conditions you have to keep in mind employing this shortcut. Now let's put them together. The first condition says hold the tip of the arrow of the force and pull it to any of the direction you want to resolve to. I want to resolve this force to the x-axis. I know that this is my x-axis, or this is my horizontal component or horizontal axis. I will hold the tip of the arrow of this force, pull this force imaginatively till it meets what? This x line. Okay, I'll pull this force imaginatively till it meets this x line. Notice that if I pull this force to meet this x line, this force moves all the way from here down to this point to meet the x line. And then the direction of this arrow, observe the direction of this arrow imaginatively now. If I make this line to align with this particular horizontal line, this arrow still points in this direction, which makes this force positive in the x-axis. So which means this is now my f of x, and it is positive in the x direction. Observe, if I pull this force to meet the x line, this force moves all the way from this point getting to this horizontal component. Now the direction of the arrow of the force still points towards where? My right. So which means this force is a positive force, f of x, in the positive x direction. Now notice that it passes through what? That's the first condition obeyed. Second condition says observe the arrow of the force. Okay, so the arrow is in the positive x direction, which means we have the two conditions obeyed. First, you pull the force to meet the line. I want to resolve horizontally, which is this. Secondly, observe the arrow. Arrow points towards the right, so which means this force is a positive component in the x direction. Thirdly, if it passes through an angle, multiply the force by the cosine of the angle it passed through. If I resolve this force to meet the x, notice that it went all the way from this point to this point, which means it covers this angle 60 degrees in this quadrant. It covers the angle 60 degrees. The third and final law simply says what? Multiply the force by the angle it passes through, you get the component in that direction. So which means f of x, or horizontal component of force, which is f of x, is simply what? The force is 10, multiply it by what? Cosine of the angle it passed through. In this case, it passed through 60 degrees. It becomes 10 times cos 60. And this is equal to 10 times cos 60 is 0.5. And that simply gives us what? 5 newtons. And it is what? Positive, because it goes towards the right. Have you seen that this is same thing as what we obtain here on a very straight line without having to solve for adjacent and hypotenuse and all the likes? Okay, you just have to solve with this shortcut and you're there on point in the same answer, which is what we have here. Now let's apply this condition now to solving for the vertical component. Let's say we don't have this angle here. This angle is beta. Let's say there is no angle here. The second law, remember, first thing to do is pull the force to meet the direction you want to resolve to. Now I want to resolve in the y-axis. I'll simply pull this force to meet the y line. This is where I want to resolve to. So imaginatively, you pull this force till you meet this y line. That's the first thing to do. Second thing, observe the arrow direction of the arrow. Notice that since this force is pointing out, if I also pull this force till it aligns with this vertical line, this force will also point vertically upwards. Okay, if I also pull this force pointing outward like this till it aligns with this line, it will also point vertically upwards, which means this is what? A positive force. So call that plus. It's simply a positive force in the y direction. The third and final rule says observe the angle this force passes through. If it passes through an angle, multiply the force by what? Cosine of the angle it passes through. But if it does not pass through the angle, you multiply by what? Sine. Since there is no angle on this quadrant, it means what? It did not pass through this angle 60 degrees. We are simply working with what? The angle on the quadrant now. It means it didn't pass through. There is no angle here, and the only angle we are given in the question is what? 60 degrees, which is on the horizontal. Meanwhile, this force actually passed through an angle here, but the angle is not given. So since there is no angle here, then we multiply the force by what? Sine of the angle it did not pass through. So this simply means that this force in the y direction becomes what? 10 times, instead of cos now, since it didn't pass through 60 degrees, then we have what? Sine 60, and this is equal to 10 times sine 60 itself is 0.8660, and if I multiply 10 to it, I will have it to be 8.66 in newtons. So this becomes the resolution of this force in the y direction. Also, it points here vertically upward, so it is positive because it points vertically upward. Again, confirm the answer and see that we still have the same result as when we went through the approach of trigonometry to solving the same problem. But you might also want to think that if here is 60 degrees, automatically I know that this angle should be what? 30 degrees. Angle on the quadrant is 90. So if the angle here is 60, it means the angle here automatically becomes 30 degrees. Now let's apply the alternate law now. If it passes through an angle, multiply the force by the cosine of the angle it passes through. So in this case now, we don't want to work with the 60 degrees. This force passed through what? 30 degrees to get to the vertical component. What do you do in this case? It becomes what? F of y equals 10. Remember, multiply the force by cosine of the angle it passes through. Since it passed through 30 degrees, it becomes 10 times cos 30. And this is equal to 10 times, once again, cos 30 remains 0.8660. You can also confirm this with your calculator. Cos 30 remains 0.860, and if you multiply 10 to it, you have it to be what? 8.66 in newtons, which is same thing as what we obtained here. So the law works perfectly fine and perfectly better. The rule works perfectly fine. Okay, so you see, all you need to do is simply what? Multiply by cosine of the angle it passed through, or sine of the angle it doesn't pass through. So we are going to take a very quick example. We are going to consider now when we have more than one force situation on the coordinate Cartesian system, how do you approach it? And then if you're able to approach the x and the y components, what are the other things? For instance, you could be asked to find the magnitude of the force. You could also be asked to find direction of the force. These are possible questions that can come out under resolution of force in two dimension or two-dimensional force analysis. So I'll pause the video now, and of course we'll consider a situation where we have more than one forces and we're asked to find magnitude and direction of force. All right, guys. So to actually explain the concept we talked about earlier, let's consider this question on the board. Question says, determine the magnitude and direction of the resultant force for the given force system shown below. So we are given a force system with 15 newtons, 20 newtons, and 30 newtons force, all inclined at different angles, and we are asked to determine the magnitude and direction of resultant force. All right, so to do this is very simple. Like I said earlier, forces that point upward there, you just have to indicate your directional component. So this is positive y. If it points downwards, it is negative y, not forgetting. If it points to the right, this is positive x. If it points to the left, this is negative x. And another concept I love to use is, I love to use the all cosine rule. Now, what is the all cosine rule? The rule which implies me to multiply the forces by only cosines and not to mix them with sines and cos. If you want to also mix them with sines and cos, you're free. If you also want to use only sine rule, you're free as well. But I love to use the all cosine rule to multiply the forces to all the angles it passes through. So for me to do that, it means I have to what? Balance up each of the angles in the quadrant. For instance, the angle here is 10 degrees, which means the angle here is going to be what? 80 plus 10, which is 90. So the angle on this quadrant is simply 80 degrees because total angle on the quadrant is 90. So 10 plus 80 gives me 90. Same thing here. The angle here is 45, which means the angle that will be here simply becomes what? 45 plus 45, which gives me 90. So I should have there to be what? Also 45 degrees. And finally, the angle here is 30, which means what is left here is 60 degrees. So I like to use all cosine rule by balancing all my angles. Okay, the next thing I'll do is I can call this my first force. So we call that F1, call this F2. So F2 equals 15 newtons, and call this F3. F3 equals 30 newtons. That's the first thing that comes to my mind. Now I need to resolve horizontal component first. You can also start with what vertical component, whichever one you choose to, no problem. So I will start by horizontal component of force. Okay, horizontal component of force. All right, let's start with the forces individually. Let's start with force F1. So you call that F1x, which means you're resolving force F1 in the x direction. Now, what does this mean? Like I told you earlier, hold the tip of the arrow of force S1, pull it till it aligns with what? The x line. That's the first law. Hold the tip of the arrow, pull it till it aligns with the x line, then observe the direction of the arrow. If this force moves all the way from here to this point, this force points in the positive x direction, pointing to your right. So which means it is positive. Then final rule says, consider the angle it passes through. This force moves all the way from here down to this point, covering this angle or this quadrant was 10 degrees. So what do? Multiply the magnitude of the force by cosine of the angle it passes through. So this becomes 20 times cos 10. And this is equal to 20 times. Let's obtain what cos 10 is. Okay, cos 10 is 0.9848. Okay, and this is now equal to multiply that answer by 20. Multiply by 20. So you have approximately 19.6962 newtons, okay? Or you can simply shorten it to be 14.7 newton approximately. Let's take it to one decimal place. 19.7 newtons, approximately 19.7 newtons. And observe that this force is a positive force because it points to the right. Also, let's resolve force F2 in the x-axis. So you call that F2x, which means resolving force 2 in the x component. Now, force 2 is 15 newtons. Let's pull this force. Now, be very careful now. Pulling this force to meet the x line. Okay, you pull this force, it moves all the way from this point to meet the x line. Watch where this direction of arrow point. You have to be very careful with it. That's why this method is very, very okay and very good, because it tells you the direction of the force easily without using trigonometry. Okay, now if I pull this force to meet this line, notice that this force points towards the left. If this force eventually aligns with this line, the arrow points towards the left. So which means this force is a negative force because it points towards the left. It is simply a negative force. And again, which angle did it pass through? It moved all the way from this point to this point, covering this angle here, 45 degrees. So that means you have this force to be minus 15. Minus because it points where? To the left. And always force that point to the left becomes negative. So you have it to be minus 15 times cosine of the angle it passed through, in this case 45. You have times cos 45. And this is equal to minus 15 times, let's obtain cos 45. Cos 45 gives us 0.7071. Okay, so minus 15 multiplies by that answer. You have it to approximately be minus 10.6 newtons approximately. So that is the resolution of f of 2 in the x direction. Also be careful for the direction. That's why we're having this negative sign, because direction points to the left, so automatically it becomes negative. Finally, let's resolve force F3, f of 3x in the x direction. Resolving force F3 in the x, same thing now, be very careful. Hold the tip of the arrow of this force F3, pull it till it meets the horizontal line. Observe the direction of this force. This force moves all the way from this point down to this point, covering what? This angle. And notice that this force is pointing out here, but if I align this force with this horizontal line, it also points to the left. Be very careful with it. If I pull this force and align it to meet the horizontal line, this force also points where? To the left, which makes this force a negative force. So that means you have it to be minus 30, multiply again by cosine of the angle it passes through. In this case, it moves all the way from here to this point, covering 30 degrees. So it becomes minus 30 cos 30. And this is equal to minus 30 times cos 30 is 0.8660. So this is equal to, let's obtain now, minus 30 multiplied 0.8660. That gives us approximately 26 minus 26 newtons, please. Minus 26 newtons. So we have this will be the horizontal resolution of the entire force. Next thing to do is summation of horizontal forces. So you sum them up, summation of horizontal forces. All right, so you sum all of them up. Now we use this Greek symbol, okay, for summation, okay, summation f of x. You simply use the symbol for summation of all horizontal forces, and this is equal to f1 of x plus f2 of x plus f3 of x. So simply adding all of them together, that gives you the summation. So summation f of x is equal to, you add all of them up now, you have 19.7 minus 10.6 minus 10.6 minus 26. So this simply implies that summation f of x is now equal to, let's get that analysis, 19.7 minus 10.6 minus 26. That gives us minus 16.9. Okay, so the horizontal component of this force is actually minus 16.9 Newton. Now, the negative sign shows that the total resolution of the force is pointing towards the left. All right, so that is it for horizontal component. Now, remember, they are asking us to find the magnitude and direction of resultant force. That's why we are doing all of this. Okay, next is to find what? The vertical component of force. So, vertical component of force. Vertical component of force. So we start with the first one, just like we've already been doing now. So hold the tip of this arrow, hold it till it meets the vertical line, observe the direction. If I pull this force to meet the vertical line, this force still points where? Upwards. If I pull this force to meet the vertical line, it still points upwards, and it passes through this angle 80 degrees. It passes through 80, it moves all the way from here towards this point to meet the vertical line. So which means it covers this angle here 80 degrees. So remember, multiply the force by cosine of the angle it passes through. That means you have here to be equal to, so we'll call this f1 of y, resolving force f1 in the y direction. That gives us 20 multiplied by cos 80. So let's do it and see. This becomes 20 times cos 80. We have 0.1736 for cos 80. So multiply this answer by 20. We have approximately 3.5 newtons. All right, and it is positive. Next is to resolve force F2 in the y direction. So I'm sure you're getting it now. Resolving force F2, still same principle. Hold the tip of the arrow of the force. Pull this force till it meets the vertical line. Now observe the direction of this arrow. If this arrow also moves to the vertical line, it also points where? Vertically upwards. It points upwards, so which means this force is also what? A positive force. And again, it passes through this angle 45 degrees. So it moves all the way from here to this point, covering this angle 45 degrees. So you multiply the force by cosine of the angle it passes through. So we have here F2y to be, the force is 15 newtons multiplied by cos 45, and this is equal to 15 cos 45 is 0.7071, and if you multiply these two together, we are going to have 10.6 newtons. So you have 10.6 newtons. Finally, for force F3, now be very careful with this. Observe the direction of this arrow. If I pull this force to meet the vertical line, notice that this arrow points where? Vertically downwards. If I pull this arrow to meet the vertical line, notice that this arrow points where? Vertically downwards, which means this force is a negative force. Now be careful. Do not pull this force to meet this vertical line, please, because this force is in this quadrant down. is not on any of the upper quadrants, so you can't put it to meet this other vertical line upwards. It's not possible. You can't move all the way from here to this point. No, it has to go with the nearest vertical line in each quadrant. In this case, this is the nearest vertical line in this quadrant, so you pull this force to meet this vertical line, and this force points where downwards, which shows that this force is also a negative force pointing downwards. And then it passes through this angle. Remember, it moves all the way from here to this point to meet the vertical line, covering what? This angle 60 degrees. So you multiply the magnitude of the force by cosine of the angle it passes through. So that brings us to what? F3y. We have F3y, and this is equal to, the force itself now is negative because it's acting downward. So we have minus 30 multiplied by cosine of the angle now, that's cos 60, and that's equal to minus 30 multiplied cos 60 itself is 0.5. So it means that the magnitude of this force is minus 30 times 0.5, which is minus 15 newtons. So after this, next is what? Summation of vertical force, of vertical forces. Summation of vertical forces. Okay, we'll use the delta Greek symbol summation for it. Summation f of y, and that's equal to f1 of y plus f2 of y plus f3 of y. Okay, so if we do this, we are going to have that f1 of y, of course, gave us here as 3.5 Newton. So we'll put it down 3.5. F2 of y, we obtain the value to be 10.6, and it is positive. So plus 10.6. Okay, and finally F3 of y, we obtain the value to be what? Minus 15. So you attach that here, minus 15. So this implies that summation of vertical force in the y-axis becomes, so let's simply evaluate this now, 3.5 plus 10.6 minus 15, that gives us minus 0.9. So summation f of y is minus 0.9 newtons. So you simply have this. Now, what this is telling you is that the horizontal component summation gave us negative, vertical component summation also give us what? Negative. So this simply means, let me take this diagram off now. I don't think I will need this again. So let's consider our coordinate system once more. We have this and we have this. We are having the summation of all horizontal components to be negative, and remember this is what? Negative component. So it means that this is now summation f of x. It appears on the negative what? Direction. Also we have summation f of y to be what? Also negative. So which means it is pointing where? Downward. It appears also on the negative y direction. So call this summation f of y. Although these diagrams are not necessary, please, but I'm just using it to explain a concept. All right, so summation f of x gave us minus 19.6. So the value here is minus 19.6 newtons, whereas summation f of y gave us minus 0.9 newtons. Now, this resultant arm or this hypotenuse that joins the two forces together is what we have been asked to find. It is simply called the resultant force. And there are two ways to finding this. That's the reason why I'm drawing this diagram to explain. It's not a must to draw this, but then this is now the resultant force from the question. Question says find the magnitude of resultant force, which means you should find the resultant force in a given number. Magnitude simply means a number without a direction. But when it has a direction, then it's no longer what? A magnitude, it becomes in vector form. We are asked to find the magnitude of resultant force. Okay, so like I said, this hypotenuse arm joining summation f of y and summation f of x is what is called resultant force. So we have to find the magnitude. Now this is now what? Triangular in shape. So to find this, we simply employ what? The Pythagoras theorem. Okay, employing Pythagoras theorem, r squared is equal to what? The sum of the squares of each of what? The adjacent sides. We have summation f of x squared, okay, plus summation f of y all squared. This gives us what? This is how to find the resultant force using Pythagoras theorem. And therefore, we can find this resultant r to now be equal to the square root of what? Summation f of x all squared plus summation f of y all squared. It's as simple as this. Therefore, this resultant r is now equal to the square root. So always take note, this is the formula you use to calculate your resultant force. Always, in two dimensions, always take note, summation f of x squared plus summation f of y squared. Regardless of how the shape is, after obtaining your summation f of x, summation f of y, then you can put them into this equation to obtain your resultant force. Always. Okay, so summation f of x give us 19.6. So we'll put it down, minus 19.6 all squared plus again summation f of y would give us minus 0.9. So you have minus 0.9, okay, all squared. So this is equal to the square root of, now be careful, when you square a negative sign, automatically it becomes positive. So let's obtain it and see. Minus 19.6 squared, that gives us 384.16 plus, let's obtain minus 0.9 squared, that gives us 0.81. Okay, so resultant force is equal to the square root of, okay, 384.16 plus that answer. So that gives us 384.97. All right, so this simply implies that the magnitude of resultant force is now equal to, you simply take the square root of that answer, and that gives us 19.62 in newtons. So this is now the resultant of the magnitude of the resultant force for that given force system shown earlier. This is now the magnitude of the resultant force. Now, magnitude simply means it has what? A number and not a direction. Now, in most cases, you could be asked to find the resultant force in vector form. If you're asked to find resultant force in vector form, always take note that your x-axis takes what? The I direction, and then your y-axis takes the j direction. So the resultant force in vector form is simply equal to, is going to now be, so in vector form, your resultant force will be always summation f of x. F of x is always in the I direction plus summation f of y. F of y is always in the j direction. So this can be written as summation f of x give us what? Minus 19.6. So this is simply minus 19.6 in the I direction, and then f of y give us minus 0.9. So you have minus 0.9 in the j direction. So this becomes what? The resultant force in vector form. So should in case you're asked, what is the resultant force in vector form? That's how you solve it. Always summation f of x I plus summation f of y j. Simply attach I and j to what? Both x and y, and you're good to go. That becomes your answer in vector form. Now, the final question we are asked is direction. Direction is the angle made between the resultant force and the horizontal line. Always, not vertical. The angle made between the resultant force and the horizontal line is called direction. So this angle theta is what is called direction. So if you do this, you can now employ your trigonometry. Remember that tan theta is always opposite all over adjacent. In this case, opposite is what? Summation f of y, and the adjacent is what? Summation f of x. So tan theta is opposite summation f of y all over summation f of x. Always, this is the formula to find direction. The direction there is theta, which means to make theta solve for the formula, theta becomes what? Tan inverse of summation f of y all over summation f of x. So this is how to find your direction. Always in two dimensions, this is how to find your direction. Theta is equal to tan inverse of summation f of y divided summation f of x. Okay, so let's do that over the other side. So from this equation now, theta is equal to tan inverse of summation f of y give us minus 0.9. So you have minus 0.9 all over minus summation f of x give us 19.6 minus 19.6. Okay, so this is now equal to tan inverse of, let's obtain minus 0.9 divides minus 19.6. That gives us 0.0459. So take tan inverse of that answer. This implies that theta is equal to, that gives us 26, approximately 26 degrees. So it means that 26 degrees is the direction of the force. So in all, we always use this relationship, r equals summation f of x squared plus summation f of y squared, to find resultant of every force in two dimensions. And then you use this relationship, theta equals tan inverse of f of summation f of y to summation f of x, to find the direction of force. Okay, if you're asked to find resultant force in vector form, then you don't need to solve using this relationship. All you need to do is append summation f of x to I and append summation f of y to j, and that becomes your answer in vector form. All right, guys, so that is a brief introduction on two-dimensional force system, or you can simply call that resolution of force in two dimensions. In the next video, I will see you with more questions on two-dimensional force system. Thanks, guys, and cheers.